Right, we're going to cover AIRC 1030C, which deals with schematics and control circuits. But you know, before we can do anything on our schematics, is we're going to have to understand some of the symbols. One thing about electrical work, I'm not, the old saying is I can't play anything but the radio. And when it comes to that, I can't read music. I wish I could, but I can't. But one thing I understand about music that's very similar to schematics, electrical schematics, is there's pretty well standards throughout the world for it. So if you see a schematic from Europe, you should be able to read it. If you see a schematic that comes in from the Far East, you should be able to read it. My understanding of music is that way. So it's, if you will, it's pretty much of a universal language. But let's keep this in mind. Y'all know what fonts are when it comes to writing? How many ways can you make an A? Several, but it's still an A. Well, symbols are that way. Schematic symbols are that way also. There's many different ways to represent a component, but once you become familiar with one or two of those symbols, it should not be hard past that point. They will be simple. Okay? Kind of like, make a little joke here. I had a fellow that, when I went to work up here at the UGA experiment station, we had a man there that had been there for quite a while in maintenance, and in one particular building, there was a lot of people from different parts of the world. And I was brand new there, and I'm walking through there, and this guy goes up to it. He's speaking definitely a foreign language. It sounded like it may have been from the Far East. I don't know that for sure. He's carrying on a conversation with him. Okay? We walk on down the hall a little bit, and we come up on somebody that was from around the USSR. This guy's carrying on a conversation with him. As we walk on down, I said, his name was Ralph. I said, Mr. Ralph, you understood those folks? He said, yeah. I speak every language in the world except for one. I said, really? He said, I said, what's that? He said, it's Greek. He said, I don't understand Greek. I said, what was that guy saying that was in that first lab? He said, I don't know, that was Greek to me. So fortunately, that's not the way schematics are. There is a standard language followed. Okay, I have a board here that has some different components on it. And these are resistors, okay? This is a heat strip. Now, what would that symbol look like? That is a symbol for a resistor. Now, if I look at that, does that tell me that's a heat strip? No. Does it tell me that it's a fixed resistor? No. But it says that it is a resistor. Well, how am I going to know that's a heat strip? Well, if I see something down here that said 4.8K, that would tell me in an air conditioning or heating system that that was a 4.8 or excuse me, KW. That's even better. That would tell me that that particular symbol represented a 4.8 kW heater. But you can see how all those different components may look different, but they do the same function in a system, or a similar function. Okay, another component that we have is a transformer. Okay, if I were to see a symbol for a transformer, the loop like that indicates that it's an inductor. Okay, and we're going to have, now on the bottom, if it's an iron core, which that particular one is, it's going to have a bar like that. That is a transformer. How do I know what the voltages would be? They should be marked. We have 120 volts, 24 here. But if I see that symbol, I know that's going to be a transformer. Okay? I see another component over there, which is a motor. This is a little shaded pole motor. Small units such as refrigerators would have something like that in there operating the fan. Well, how could that be shown. It could be like that. FM, fan motor. It may actually show the windings of the motor. Y'all see something that looks similar to the transformer? That's because that's an inductor, but that could actually be FM, the fan motor. Back to the different fonts that we talked about in the alphabet. They don't look all that much alike, but they still represent the same thing. And once you get to seeing that, you'll get accustomed to that. Okay, what about a contactor? I have a contactor on that board. I also have some relays. These are relays. Actually, I don't have a contactor, but the relay and the contactor are going to look the same on the schematic. For example, if I have a single pole contactor, I'm going to have the coil, the board, and I'm going to have the contactor. Okay? If it were a two-pole contactor, there we go. What if I had a relay that was both normally closed and normally open? We could actually draw it like so, with the coil there. Now, something to really get in your mind, and folks have a lot of problems with this. These contacts in this coil may not be next to one another in the schematic, and you'll see that as we draw some schematics. They're the same component, but their electrical operation may be dictated in different parts of the schematic. Okay? Just because they're not side by side doesn't mean that it's two separate components. And you'll see that as we draw them. Okay? Now, what about a fuse? Y'all see the fuse on the board over there? Right here. Let's take a symbol of a fuse. We could have something that looks like that. We may actually have a block like that. I have seen it actually look more pictorial and be like that. So, like I said, keep in mind there's different ways of drawing the things. I just mentioned a word that I need to bring out. Pictorial. Two basic types of diagrams that you'll deal with. One is going to be pictorial. The other is going to be a true schematic. Okay? A pictorial schematic will actually have symbols on there that look more like the component itself. And usually they're going to have a wiring diagram that's going to actually look like the wires going to the different components with the different conductors in the cables. To be quite honest with you, those are very hard to troubleshoot off of. They're very good for locating components and identification of components, but as far as the troubleshooting, they're very, very hard to do that. Okay? I prefer, anytime I'm working with something, a ladder type diagram. Okay. Let's draw us a ladder type diagram. Now, before I get away from it, you have some relays. You have a potential relay, just so that you'll know this in the future. That's basically what's on this particular board. As you well know, that is not all the symbols that you'll come across. If you refer into the book, there's a good list of them on page 565 that will take you through many different components. Understand though that that's not the only place that you're going to find a list of components. Hopefully, you will have a legend with a schematic that will help you identify the different components within that. What's fun is when you don't have a legend. And that can be kind of trying, but you'll figure it out. It's back to like I was talking about music. I can't read music, but I've never seen a pianist that could that opened up a page of music you couldn't read it. I'll stick with the radio though. Yeah, okay. All right. Let's draw us a ladder type diagram. We did some of this the other day, but we're going to have a little more of it. L1, and L2. Sometimes L2 could be called a neutral. It depends on the circuit. I like to think of it as the sides of a ladder, and then you have the rungs of the ladder in between. This is where your components are going to be, and your controls. Let's say that we have a motor here. Okay? This is me, I like to put my loads on this side as much as possible and put my controls on this side as much as possible. It just helps in drawing, it helps to be able to see it a little better. For example, let's say that we have a switch operating that motor. You can see the rung is a circuit. Now, there's different ways to do this, but I'm going to show you something that I like to do, and that doesn't mean that